as we all know that security in general has become, a huge deal because of what organizations can potentially lose to breaches, unauthorized access, hacks, and all that. So today we'll be considering the topic authentication and security with KeyCloak. So today we have brought to us one of our special mentors who will be doing just this topic. Let me not take for time for that. I'll bring in on board Tolulope Fabunmi. So hi Tolu, thank you for joining us.
Hi. Can you hear me loud and clear?
Yes, we can see you.
Okay, and you can see me. All right. I'm happy to be doing this evening. First and foremost, I want to apologize as per mother in tech. The kids are around, and so the background noise might be an issue, but please bear with me. Let's have a beautiful time. All right, so what we are looking at today is authentication.
Only runs that one.
Authentication and security.
So you have to make your card expensive.
And
you like that game? You have to fight.
Okay. A quick background story. Can you see my slides? All right. Okay, so a quick background story that I would love to share is that application security has become a critical concern everywhere today, with security breaches causing organization huge loss of data and millions of dollars. So every application today basically needs a trustworthy solution. Can you hear me?
Yes, we can hear you.
Okay. All right. And so every application today needs a trustworthy solution for managing its user identity and access. And then we'll be breaking things down because the topic is authentication. It's talking about application security. And then we are looking at a tool that will be used to secure and also authenticate the users of the product. All right. So looking at what is application security. Application security is the practice of using security software, looking at using hardware, looking at techniques, looking at best practices and procedures to protect computer. To protect computer applications from external security threats. Security was once an afterthought, in former software design. Security was always something that was thought of at latter times. But today it's an increasingly critical concern for every aspect of application development. And so the volume of applications developed, distributed, the volume of application used, the volume of application patched over network is rapidly expanding. As a result, application security threats, it becomes the more the volume, the more the threats, and then even the kind of data that is being acquired over time, requires more security practices, like best practices that to protect your product and also protect the users of the product. I mean, everyone would tell, if Facebook, for example, now, or let's say CBN is under attack, and then you realize that all your bank verification number, your BVN is at risk. It's a whole lot of pressure, even on the users for, as a user to now trust the banking system again will take quite a long period of time. And so that's how important application security basically is. And then I want to ask a question. And at what phase? Now look at these are the 7 phases of the software development lifecycle. We're looking at the planning stage, the phase of defining the requirements, the design and prototyping, software development, testing, the deployment, and the options and maintenance. And the question is, at what phase in this cycle, in this life cycle, should application security be analyzed? Can I get quick answers? At what phase? Is it from the planning phase? Is it at the phase of defining requirements? Is it at the phase of designing and prototyping? Is it at the phase of development? Is it at the phase of testing? Or is it at the phase of deployment and maintenance? At what phase should application security be analyzed? So please, I want answers. I want to be sure that I'm not the only one in this place.
Okay. Hi, Tolu. My name is
Hi.
Tolulope. Well, in your opinion, I would say at every phase of software development cycle, you should consider security. Security is too important of a concern not to be considered at any phase at all. It's my opinion, though. Thank you.
Thank you. Thank you so much. Thank you so much. I have a response here at the deployment phase. Okay, thank you. That is why we are on this call. That's why we are here, so that we can provide answers. So for me, at every phase of the life cycle, basically, is when application security should be analyzed. And that will lead us to the question that this topic we are looking at, this authentication that we are looking at, application security that we are looking at, who needs this knowledge? Who needs this knowledge? And we look at it as the knowledge of application security is important to the following people. And you agree with me that the product owners, the product managers, the people that are owning the product, people coming up and saying, okay, I want to build like a telemedicine application. From the point of owning and saying, oh, I want to manage this product, they are thinking about the security. They are thinking about people's data that will be released to them. You're looking at medical information, and then you have to start thinking of how to secure the application from as early as start. Then we look at the product designers, people that are going to design this product, that are going to come up with the user interface, the user designs that we are going to see, the login page, the sign up page, and other important pages. They need to understand. They need to understand application security. Another person that is important for them to understand this knowledge are the developers. While they are developing, they need to put security into eyesight. I'm so sorry for the background noise. I'm so sorry for the background noise. The boys are home. Okay. Another person that looks at application security are the product users. I need to be sure that my data that I'm sharing with a banking mobile app will be secured. If not, what is the essence? When BVN can just be stolen at any point in time, my data can be used up at any time, and my trust can be breached. You understand? So at the end of the day, when you look at all of this, when we look at the whole process, then you realize that everybody practically needs this knowledge. Okay, so we look at securing applications. And when we look at securing applications, there are some very important questions that we need to ask. So who is responsible for providing security? Let's look at it. Who is responsible? I've mentioned that it's important that the product owners, the product managers, the developers, designers, users are looking out for the security of the application of the product, the software product. Now, who is responsible? For those that are concerned with cloud providers, especially AWS, there's this model called shared responsibility, AWS shared responsibility. And AWS shared responsibility states that for physical infrastructure, talking about the data centers, talking about the physical infrastructure for your data. It is being secured by AWS, while every application that you have seated on the cloud should be secured by you. So part of the things we are looking at also the design considerations. There are some principles and best practices that needs to be considered whenever we are looking at securing applications. One best practice that I look at that is something that we do every single time is giving least permission at every point in time. Least permissions. Maybe now you want to share a Google document. You as a user, you are not sharing to people as editors. The least you can do is say, okay, be a viewer. And then maybe you want to go a step further and say, okay, you can comment. But editing means if you are asking someone, you are sharing that document and giving the permission to edit, then the data or whatever information you have on that document can be tampered with. And so these are best practices. These are considerations that we need to look at. Another thing about securing application then will be coding. Now, the coding aspect would involve, okay, the backend. How are we writing out the backend code? How are we writing the front end code, the web code? How are the mobile guys? How are they developing the code so that, okay, can a cyber thief, a cyber person, or an hacker, can the person just come in through the login page and have access to all of this information? And through the coding, we are looking at, okay, what ports are exposed? Can a normal person just guess a port? So these are part of the best practices, the ideas, the techniques that we look and put into place. Another thing that we are looking at, like if you can see my screen very well, we have a house that is chained, and then you can see the security. And part of the basic things about security is authentication. Authentication says, who are you? Before, like when you go to a big man's house, let me use that word, a big man's house, and then you knock on the gates. You get, who are you, from where? And you need to identify yourself before you can enter the gate. Now, a big man's house, it has a security guard, it has a cook, it has a chef, it has washermen, it has maids and all that. And then you realize that the security guard cannot enter the kitchen except he is given permission to come in. That is, who are you? Who is the person coming into the kitchen? The cook also cannot enter into the bedroom because the cook or chef is not cooking. It's not cooking inside the bedroom. So the chef has access to the store, the kitchen, and then his or her room. While the maid, who is in charge of cleaning up the whole house, now can, okay, maybe to some extent, have access to the bedrooms, the sitting room, and co. And then the trusted ones now have access to the master bedroom. So basically, authentication means, who are you? Authorization says, what are you allowed to do? As a security guard, you are not allowed to cook. Privacy is the encryption of maybe the information that is being shared from maybe the front end to the back end. The API is being sent, the token is being sent, and all that. It needs to be encrypted so that an hacker cannot just pick up that part of the code and then, oh, voila, he has access to all of the database. Now, can anybody see what you do? Now, when there's an handshake of tokens between applications and all that, can anybody see what you do? Is there a way that when they see it, when it's being seen, like anybody can just pick out information? It should be the encryption should be so secured such that a random person cannot pick up information even from what we have. Then data integrity, can anybody change your action? Like the example I gave, the example of The example of the Google document I mentioned, when we said that you have the viewer option, the commenter option, you have the editor option. Now, can anybody change your action? By the permission you have given, can anybody change the action? And that leads us to, this is a house, and you can see it has different security patterns, different security techniques. Now, for the scope of this class, we might not be able to mention all the different security techniques that can be used. But like this house, you can have your CCTV, have your key, have the password, have the Wi-Fi, or the Wi-Fi wall, what do you call it? This wirefall. You can have a lot of protection or security even for your house, the products that you're trying to build. Another thing we'll be looking at, like I said, the topic is authentication and security with KeyCloak. So we're looking at what is authentication. And authentication is, from what we see, what we saw in the last two slides, authentication is who are you. So authentication is a process of verifying the identity of a user or information. Authentication is simply saying, who are you? Or when you identify yourself, like, let us know. Let us know who you really are. You understand? Okay. And then I want to use this picture, this user face, to show you what authentication is all about. A user story. Now, can you see my cursor trying to scale over this dark blue box? So we have a person that uses the website. Now, while visiting the website, see HTTPS. Now, this is a security rule through the web server. And then he visits the website, visits a front end, like the web app, what you can see, your login page, your sign-in page that serves the website. Now, when it says the information and types in his information, now there is a service called the API. That's the backend service. Now, this service, hello, yes?
Your slide, I don't know whether you want to change your slide or something. It's
Okay.
still
Okay, let me see.
social security basics. Yeah. Okay.
Okay, let me go back. Okay, I'm coming. Let me share again. All right, can you see my screen now?
Yes.
Yes, yes.
Okay, so you can see the navy blue, the blue, what's it called? The blue box of the user visiting a front end, like a UI, a web app, basically, or a mobile app. And then it visits through HTTPS. HTTPS is also a security, it's a security practice. You have to secure your website. And then, so when the data is being passed, it goes to KeyCloak, which is a system of single sign-on. Sorry. Okay, sorry. We a single sign-on that authenticates and says, okay, this person, we are verified who this person is. We can authorize the user, and then the backend also verifies from KeyCloak and says, okay, we know this person. Yes, we know this person. This is his information and all that. And then it can move back to the front end, and the user can get service, can get response from the request that has been made. All right. I'll quickly run through this. We have, for web application, even for your mobile application, we have so many methods. We have methods of authenticating, of verifying who the user is. We have the first one I'll be looking at is the cookie-based authentication. Now, cookies are generally used to undo authentication in web application. From our diagram, you can see a client, that's the browser, the user. sends maybe the username, sends a password to the server. And one way to authenticate that the information is correct, to authenticate or verify the credentials, you get a 200 code. A 200 code means successful. 200 or 201 gives a successful answer, and it returns to, it sends the post request for login credentials, then the server verifies the credentials sent to it, gives a 200 characters code, it creates a section ID, stores it, and returns it to the client. Now, on subsequent requests that this user sends, or this section ID from the cookie, because the cookie has been saved on maybe your local machine. That's why most time when you visit a website, you see accept or decline cookie. Now, this is like, this is message is like a memory store that is kept locally on your system. Now, when it is stored on your system, the cookie is stored, cookie is verified in the server for subsequent requests, and the corresponding request is processed. Now, when you log out of the app, your section ID, because cookie is quite ephemeral, the memory is very temporary, it gets once you are out, it gets cleared out. So that might not be the perfect way to kind of verify or identify who is who. Then that leads me to the next authentication method in web application, and we're looking at token-based. Most times, and token-based is like the most common way of giving authentication, token-based authentication, and it's called the JSON Web Tokens, JWTs, and it is a standard, it's an open standard that defines a contained way. You remember we mentioned encryption. It has to be encrypted. Your data has to be encrypted. It has to be secured. All right. So JWTs, they give a contained way to transmit information between parties. So it is encrypted. Nobody can change it alongside. Remember the security basis we talked about. So it is encrypted. It can't be tampered with alongside. And when these credentials are received from the clients to the server, what's it called? The tokens are now shared in between. So token is validated, and once it is validated, the person or the user, the client, can then have access even to get response for the request he has made. Now, the other authentication method that we are looking at will be the third-party access authentication. That's via API token, the use of API, and then through open authentication. And open authentication.
So we're still on the cookie base. Yeah, still showing the cookie base.
Oh my goodness. Shit. Is it still on cookies?
No, it's not on the move it away. It's on the token based. Okay.
Right. So the open authentication. So like I said, it's an open protocol. It allows secure authentication method from the web, mobile, and desktop application. Now, it authenticates the server as the user. The server contains a database that stores your data. So if you're someone that has come, the client has come before, and then maybe he has a role assigned, definitely. So when he comes, it is easier to authenticate that, this person has been verified in times past. This is a user that has visited this product over and over. Then we have the Open ID. So Open ID is a form of protocol that allows identity provider, we call them IDPs, not the Nigerian IDP, but identity providers to validate a user. That's why sometimes when you visit a login page, a website sometimes, and then you're trying to create an account, and then you see the option of sign in with Google, sign up with Facebook, or sign up with email. Now, we believe that Google is like an identity provider. Google as over time has your details. Google as can identify, can verify that, oh, this person has the age, because on Google you have your age stored, you have your email stored, you have the name stored and all that. And so these service providers, Google, let's say LinkedIn, there are some profiles I'll say, okay, for Facebook now, Facebook will say, okay, can you sign in with Instagram? Or Instagram will say, okay, let's use Facebook and all. So they provide a way to achieve a single sign-on, so that once you click on that login with Google like this, you are Fenta. You understand? And it's possible because we believe that those providers, the identity provider, have validated that this is the user. Remember, the home goal of authentication is to say, who are you? Who is this person? And that is the end goal. So how through using your cookie-based authentication, using token-based, using third-party access, using OpenID, the end goal, even with security accession markup language, SAML. So that's more like jargons, but also a form of authentication using the XML format. Now, the end goal, like I said, is that we can verify and say, this is who you are. Okay. Now, all through, if you remember, all through authentication, I mentioned cookies, I mentioned token. There is a word called access token, and it is a code that is used for authenticating a web or mobile application so that the person can access specific resources. And all through with authentication, there is always a token, because there has to be an handshake. Okay, I have this information, I'm giving you this information. The backend calls forth a token, an access token, and then because it's a code. And like I'll teach my teenagers, I teach them that code is a language, basically. It's a language. So access token is a language basically used to verify that this person is this person, who is who, and this person can access specific resources. Another word that we'll be using so well, because we are looking at authentication, we are looking at security with KeyCloak, is identity and access management. We call that authentication is who are you, identity, and access management is what can you do, authorization. So now IAM, identity and access management, ensures that the right rules, the right people in the organization can access specific resources they need to do their job. So I'm saying that IAM means the right rule can access the right words needed for them to have their job done. So I'm saying in an organization where I have the administrator, I have the accountant, I have let me say like the cleaner now. I'm saying my access management will be the cleaner, or let me say the receptionist, does not have access to the company's accounts. That should not be part of the resources the receptionist should have access to. That is what IAM is all about. Looking at the story of the example I gave of that big man, the big man's house, the security guard should not have access to the kitchen. The security guard should not have access to money, to the money of the teacher, or the money of the parents, of the security guard should not have access to the children's school bag, their books and all that. So identity is who, access is what, and how we can manage ensuring that the right rule and roles in the organization can access specific resources they need to do their job. And this is where KeyCloak comes in. So KeyCloak is an open source is an open source identity and access management tool. And then, like I said, KeyCloak will verify it will tell us who this person is, what permissions does this person have, and then okay, can this person sign in with other single sign-on options, the identity providers like your Google, Facebook, and other things. So we have, it does this, KeyCloak does this through maybe the identity brokering and social login, like I mentioned, through the identity providers, the user federation. We're going to be doing practicals, so it's not just talk. So we have the client adapters, we have admin console, and an account management console. All right. Then, so we're going to look at how KeyCloak works, the procedure that it works with.
I'm trapped inside this cage for ages. He's living hell. And before I learn, remember, before my happy days were over.
Hi, I'm coming. Okay, all right. Okay, so we're looking at the working format or the workflow for KeyCloak. The workflow for KeyCloak. So like I mentioned, a user comes in, a who comes. User enters the URL of an application. Now, the user is trying to go through the application, all right? He's trying to go through the application, but then the application, the normal and the best security practices, the application directs it to KeyCloak. Now, the way KeyCloak works, the way this authentication happens is that you will not see KeyCloak's login page. That's the best security practice. You won't even know that there is an option of a security body like KeyCloak that identifies, that gives access and can manage all of this. But the user enters the URL of an application, the application redirects to KeyCloak. So all information that is being prepared. So like I said, the product designers, they are part of this architecture. They are part of the people coming up and saying, okay, this is how it's going to look like. So their login page, the login page might look, it's because we are trying to protect our products. The login page would necessarily not be KeyCloak's landing page, so that an average person would not even know that there's something called an SSO or a KeyCloak or an IAM that is securing the product. Now, so it redirects to KeyCloak, and from KeyCloak, it takes the user back to the login page. Now, the user now gives credentials, the name, right? The name, date of birth, all those information, password, and all that. And so KeyCloak is the one who validates this user. Oh, okay, this person has access. This person can use this product. Okay, all right. So let us validate, and then KeyCloak now validates, redirects to application. Now, in a case where the credentials and all that has been said, that has been typed in, is invalid, what happens is that KeyCloak now send it back to sender. They are not here. You understand? So what has happened in the frame of this is KeyCloak has identified and cannot give access to this particular person. So KeyCloak has said, okay, this is who you are. You are not part of the people that are expected in this place. You are not expected to be part of these people. So you cannot have access to what? I believe that is clear a bit, all right? And then that takes us to how the other workflow for KeyCloak is using the OpenID Connect. OpenID Connect also is more like what we have. So this is the application, the client types in what he wants to do, redirects the browser. There's an authentication request. I'm sorry. I'm so sorry. Okay, so the authentication request login page. Lucas, stop. Okay, sorry. So the application, the client is trying to respond to the application. But in this context, you can see that the client, that's the web browser. The web browser is in between KeyCloak and application, like is interfacing almost directly with KeyCloak. So KeyCloak at the end of the day still does the same thing as validating, redirects to application. Then, sorry. Okay, I'm sorry. So we have a visitor. Okay, yeah, so like the process still remains the same. The process remains the same. Entering of the login details, submit login, there's a validation that happens, there's a redirection to the application, the page request, there's a page request, token is requested for, there's a validation, and then tokens are being returned, a back and forth. But ideally, the concept remains, let us authenticate, let's know who you are and what resources do you have access to. All right, so at this point, I don't know if you have questions because we want to do some hands-on. If we have questions, we can just type them in the.
So what's the difference between the first method of authentication for the KeyCloak and the second one we just mentioned?
All right. So the difference is the location. It's more like the architecture location. For the one I first said, you have KeyCloak being an interface between the application. But this time around, there is the application here, the client is here. The client is, it's more of the architecture, basically. More of the architecture, how KeyCloak is being, of how KeyCloak is being placed. So it's either you KeyCloak to interface directly so that when people come in and then they see, okay, they see the login page. So the login page is, oh, that of KeyCloak. Okay. And then that's the difference. It's just the architectural structure, how it's being placed. So it's now boils down to the design, that the product, the entire development team, what exactly do you want to do? Do we want such that people can interface directly with KeyCloak, or we don't even want the user to know that KeyCloak exists even in this architecture design? So that's kind of the difference. Is there any other question or?
Sorry, I did not really get the token-based authentication you explained. Is it the same as the KeyCloak one?
Okay, so I'm coming. Sorry. So when we talk about the workflow between the web app and what is going on in the back end, what's going on with the in the back end, basically, what happens is that there's a back and forth of tokens. There's a back and forth. It's like an handshake of, okay, I'm sending you an information. So tokens is like it's like a code. Like I said, it's a code. So it could be jargons like JXW, blah, 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 blah. But it actually contains the information that is needed in the backend. So it is stateless. It is stateless. It can never be stored on the server. And token is basically passed on to the server and it gets decoded. Like I said, it's a code. So it's just what goes on between the handshake between the backend and KeyCloak. So KeyCloak also generates tokens. KeyCloak is a tool. It generates tokens that interacts with the API. Normally when you're building a product now, we have the web app guys, those that are building the UI, UX thing, that are building the login, the backend. And so we have the backend guys that have written like an application program interface. They have written out the APIs that are instructions. Okay, when the user ID comes in, the user ID should be stringed, should be a string. Or when this is coming, it should be an array. They've written out API specifications, and then they have now built out what requests, what errors should be given, what logs should be placed, and all that. Now, with security in mind, with KeyCloak in mind, what we are doing now is, okay, when the user types in their information and says, oh, okay, let me give a practical example. Like you're trying to build, okay, for your mobile application now, your mobile banking application, when you log in as a customer, as a user. Now, when KeyCloak as a tool, which might not be the tool that is being used for our mobile banking apps, now, the information states that we're a customer. And from the backend, in the API specifications that have been written, I'm saying that the user role is customer. So when an admin in the bank wants to log in, the admin is logging in as an admin. So the token that is generated by KeyCloak, so when KeyCloak now sees the token that reads, oh, this person is a customer or user trying to log in as an admin, it's send back that information because that token has generated or has verified that this is a wrong user. So tokens are codes. They are just, they are decoded, they're encrypted. Basically, they are codes, they are, how do I put it now? They are jargons, but they are handshakes between KeyCloak, if KeyCloak is the tool used. So I want to clear up that KeyCloak is not the only security tool, the only IAM tool that is used in building products.
Yeah.
All right.
Okay, thank you.
Okay, any other question, please? Can I go ahead? All right, so like I said, I want to do some hands-on. Let me share my screen again, and then I'll just give a simple example of KeyCloak. So this is a KeyCloak, a sample KeyCloak. I'm sorry, I have to log in again and all that. It's a test KeyCloak page. All right. So part of the things about KeyCloak is very secured. And so you cannot type in, it has to have this secured SSL certificate. It has to be secured. If not, you will not be able to deploy your KeyCloak. That's story for another day. But then once you have your KeyCloak installed, then you type in your credentials. And I hope you can see my screen. So I'm not just talking to myself. Can you see the KeyCloak screen? Yes, it can be used for 2FA. Yes. Yes, it can be used for 2FA. Yes. If somebody asks that, can it be used for 2FA? Yes, it can be used for 2FA. So basically, this is the usual. So KeyCloak comes with realms. So it has a master realm, which is like the master Oga. When they say master, master is master anyways. And then we have, you can create your own realm. So for the scope of this class, I'll be doing a test one. So let's assume that I am trying to import realms. I'm trying to import from maybe a KeyCloak realm that I used to use. And then I want to export the information into this new one. So I can just import, select file, and then I have all of this back here. Now, I am not importing because it's a test. Just I want to test and just enjoy ourselves here. All right, so the realm has been created and all that. And one of the things I am doing, I need to set up this. I need to set up this and pass the information to the backend team. So the backend team they now have access. They have access to all of this. They have access. They have their tokens here. I have my part of the settings that I'll be using here. And one thing about KeyCloak, although when you go online, I try to get information about KeyCloak, the information might not be encouraging basically, but then you can always ask questions when you are stuck. Okay, so with this information, you can see the OpenID endpoint configuration here. I have my HTML to identity providers here. Save. If you remember, we talked about identity providers. So this one, it allows external ID providers or social network. You can see as well as Google, your GitHub, Facebook, and Twitter. So you can add provider. Okay, I want to add GitHub so that any configuration I'm making with the backend team, now they can be allowed, basically to use other social login to sign in into the product that we're trying to build. So those are the identity providers. We have roles in this point, at this setting, you can add roles. This is where you are able to tell you're able to say, okay, I want this person to be an admin. And I say, oh, this is the role assigned to the admin of test. Okay. Now I've created an admin. There's an admin here. One of the things I would do is I need to give now we can have users in the role of admin. I have the permissions that I can give to this person. So at this point, I say, oh, policies that add a number of things basically. And it is not a one-time off thing, but it's just for you to see that we can create so many rules. We can create, we can assign as many as possible. So that somebody that is an admin will not have permission. Someone that is a user or a patient for maybe a telemedicine app or a banker now, a customer would not have access to that of the admin that can sign check, that can approve, that can approve all this process. Now you're asking for a loan of 1 million naira and then or maybe a loan of 10 million or 100 million now, and a user can just sign in and come in and say, okay, I am the admin. What that does is there's a breach. The fact that there is no sign-in, there is no security, there's no identity manager like your KeyCloak, it means that what that does is a common user like that can just have access and approve some transaction, and that is the end, basically. All right. So another thing I'll show is the client. So we have the clients, you have the admin CLI. From your admin CLI, you can give rules. Okay, I want to add rule. I want to add rule this admin. Save. I want to add users to this role. I want to add users to this role. Maybe I've created users. At this is where you add user on KeyCloak. On KeyCloak, when you want to add a user, let me say, okay, I'm Tolulope. All right, I'm Tolulope Fabs, and this is my email, and I'm saying, no, Tolulope Fabs. And then I'm using Tolulope. Okay, it's here. Okay. And then I can save. Okay, says no. Okay, my email cursor did not hide that blah blah blah. .com. Okay. All right, so the user has been created. So I want to map a role to this person. Now, I have available roles here. I have admin. Remember, we created a role, admin role. And so I want to assign an admin role to Tolulope. So I'm doing add selected. So you can see now I now have assigned role. I have admin added to my user as a user. I have admin assigned and all. So now part of the things part of the questions that was asked was the tokens. So I want to show you so these are tokens, settings for your tokens. Okay, your section ID. Basically, these are security settings, your configuration. Okay, how many? So how many minutes do you want your access token to last? How many minutes do you want it to last? All that. Hello. Hello. Okay, I think it's muted now. All right. Sorry about that. Okay. All right. So I can say, okay, require SSL. For most requests, I would say, okay, require SSL. Ensure that the login URL is secured. It has to be secured. It has to have this padlock. This padlock must be there. It's important. You understand? It has to be secured, and all. Okay, quite a number of things here. I have authentication here. I have the user federation. Okay, maybe I want to have external user database and all the groups, the client scopes, the RAM settings, and a whole number of things. So these are many things that we can actually see, that you can see KeyCloak. And it's beautiful now because we are looking at it. This is a tool that can be used, and maybe for a DevOps person, DevOps engineer, or a cloud engineer, or a backend, or a software developer, and don't find that you at least have an idea of this IAM tool, and
Please, I've got a question.
Okay.
What's the difference between, for AWS, they have IAM,
yes,
and they still have Cognito? Is Cognito the same? Because what you explained now looks like Cognito in my eyes, but then I know that there is IAM. So is IAM part of Cognito, or KeyCloak is like a bigger KeyCloak includes IAM and Cognito together?
Okay. What do I have to say about it? Okay, so IAM is very interesting for AWS. Don't mind, I'm an AWS ambassador. When I compare AWS to Azure or GCP, and IAM for. Sorry, can you hear me now? Hello?
Okay, I can hear you now.
Okay. So like I said IAM for AWS is interesting because they are protecting not just an application. IAM for AWS is you are protecting the entire environment. IAM for AWS means I can, for your roots environment, AWS, we call it the RDS, that's the database, the storage buckets, your CloudWatch, your billing system, and all that. With IAM, you can actually say this is the amount of persons, these are the roles, these are the identities, these are the who I want to have access to the billing account. this person, I don't want this person to have access to the RDS. I want this person to only be able to access an EC2 instance. That's the IAM for AWS. Now, KeyCloak is an open source tool that has both the IAM and can interact with the backend. So IAM for AWS is for the entire AWS environment. So it's not just I want to build a product, but KeyCloak is now focused on, okay, I want to build a product. Who can access what? Who can access what? What tokens can I share? And other decoding and every other thing. So this is open source, it's free.
Okay, so like IAM is like a bigger identity management system, while KeyCloak is just for that application you're
for the
trying
product you are trying to build. Yes,
Okay.
yes,
Thank
yes, yes. Thank you so much for asking the question. Do we have any other questions? Any questions? We've shot beyond the time we proposed. Any other question, feedback, contributions? If you have used KeyCloak before, maybe there's something that I missed out and all. So like the question that Michael asked about multi-factor authentication. So part of the way that KeyCloak gives two-factor authentication is it sends OTP, one-time password. So now let's assume you registered with your email address now, or maybe your phone number. Now it's with your integration with the backend. That's why I said KeyCloak does not work alone. KeyCloak you have to work hand in hand with the web guys. You have to work with the backend guys. Like everybody's in sync, everybody's integrated, you understand? So that there's a part of the structure of the architecture that involves sending OTPs, sending one-time password that the user would verify. If you recall from, I'm coming. I want to go back to the slide I shared. Like if you recall, there's this part when I was creating a user, it asks if the email has been verified. That's part of the 2FA authentication. It will ask if my email has been verified. The email I typed in, which is not verified, I have to verify that email. So I said I should share that aspect. So if there is no other question, I want to say thank you for coming. Can you see my slide? Yeah. So I want to say thank you for coming.
Thank
you. Then I want to hand over to Tolulope Fabunmi. Is he still here?
Yes, very much.
All right. Thank you so much.
Thank you very much, Tolu. This was I'm very certain that it was insightful for everyone as it was for me. Thank you for taking us step by step through this particular topic, and we're really grateful. We hope that
I told you, you are sounding quite far away from the mic. I can't hear you.
Okay, can you hear me now?
Yeah, it's better.
Oh, apologies. So I was saying thank you to Tolu for taking our time to walk us through this particular topic. It was insightful for me. I'm certain it's the same for every other person that joined us today. Thank you so much. Everyone, thank you for tuning in today. I'm sure that it was a great session for you too. So as we've been doing for the past 3 weeks now, I will share shortly after this meet, either today or tomorrow. I will share a feedback form link to everyone who tuned in, just to be able to get the feedback about the session and prospective topics that you would prefer that we we discuss, things that you want us to talk about. So would like to hear your point of view. So yeah, that's it for today. Thank you so much for tuning in. We'll see you same time, same place next week. Have a wonderful weekend ahead.
Good evening. Good evening. Don't go.
Good evening.
Don't go yet. I'm not in your squad. Which squad is this? I joined from the building. Please don't go. The thing is, I'm a business